Is consciousness a byproduct of complex computation among brain neurons, or does it emerge from the quantum realm, a mysterious and fundamental layer of reality? One theory, daring to bridge the gap between consciousness and quantum physics, is the orchestrated objective reduction theory, or Orch-OR, a hypothesis that has both intrigued and divided the scientific community. Orch-OR, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggests a radical idea that consciousness springs from quantum computations within microtubules, cylindrical protein structures inside neurons. According to Orch-OR, these quantum computations undergo a coordinated collapse, a process called objective reduction, due to an effect of quantum gravity. Each collapse, the theory postulates, is a moment of conscious experience. But how plausible is this? To find out, one must journey through several key areas of investigation. Firstly, the quantum nature of microtubules. It's critical to explore the scientific feasibility of microtubules being capable of sustaining the type of quantum states Penrose and Hameroff propose. Experimental research seeking evidence of quantum coherence in microtubules also warrants thorough analysis. Secondly, the nature of objective reduction as a physical process and its potential to give rise to a unified conscious experience. This requires delving into the depths of quantum physics and interpretations of quantum mechanics. Thirdly, a critical review of experimental attempts to test the Orch-OR theory or find signatures of the proposed mechanisms is necessary. Lastly, the theory faces numerous criticisms that demand attention. Can the warm, wet and noisy environment of the brain really support delicate quantum processes? Does Orch-OR truly explain the qualitative nature of consciousness or the unity of our subjective experience? And what of the arguments that the theory doesn't provide clear, testable predictions, thus lacking falsifiability? By addressing these areas, one can evaluate the strengths, weaknesses and major critiques of the Orch-OR theory. This approach, a deep dive into a specific, well-articulated theory like Orch-OR, offers a concrete example of how attempts are being made to connect quantum physics with consciousness. Whether Orch-OR stands the test of time and scientific scrutiny or falls by the wayside, it undeniably represents a bold step towards solving the enigma of consciousness, pushing the boundaries of what we consider possible. In conclusion, the Orch-OR theory presents a compelling, albeit controversial, attempt to decipher the complex relationship between consciousness and quantum physics. By delving into the plausibility of quantum computations within microtubules, the nature of objective reduction, the experimental support for the theory and its criticisms, one can gain a comprehensive understanding of this groundbreaking hypothesis. Regardless of whether it's ultimately validated or debunked, Orch-OR undoubtedly illuminates fascinating potential intersections between consciousness and the quantum world.